Good morning all. Hope y'all's doing all right out there. Now here, we're going to test this IGBT. Odd thing about the drive that this IGBT came out of, it had a blown bus fuse. The bus fuse had opened up. But I tested this IGBT good with my meter. It's not shorted, so I don't understand why that bus fuse opened up. But I removed the IGBT from the power board, and we're going to test it with this setup right here. Now, if it looks a little bit confusing, it is. It even confuses me every now and then, but I'm the one that designed the circuit. When you see my drawings of this circuit right here, it'll make complete sense. So, inside this package right here, we have 6 IGBTs, but we only test one at a time. And that's the beauty of this circuit right here. Now the part number of this IGBT, it's manufactured by PRX, and it's part number PM15CKF120. And we have to power up each individual circuit from an external power supply, and I'm using plus 15 volts applied to pin 3 and the ground from that external power supply to pin 1. And we are going to check the high side U first, and that's why we power up 1, 2, and 3. Let's put this on. The red lead is attached to the P terminal, and the black lead is attached to the U terminal. Now again, pin 3 is VCC of the U high side circuit. Pin 1 is the ground. Pin 2 is the gate input to that high side U IGBT. The red clip lead is going to our light bulb load here. And the black clip lead is going to bus ground. I'm going to take a variac and apply it to this bridge rectifier over here and filtered by that bus capacitor. Now our circuit right here uses 2 power supplies. One, I have 5 volts from one power supply powering up this oscillator circuit using a 555 timer IC set in a stable mode. And that's driving into the input side of this optocoupler. Now, 15 volts, the same 15 volts that we're powering up that high side U circuit, is in our NPN transistor circuit right here. The collector of the NPN transistor is driving into the gate of the IGBT. The output of the optocoupler that's being oscillated by the 555's input side, the output side of the optocoupler is driving into the base of the NPN transistor. Phew! So I have the variac. We're going to vary the DC bus voltage with this variac right now. Right now it's set to 0 volts, and it's unplugged from that power strip over here. That power strip is the same power strip that's powering up our 2 external power supplies to power up our circuitry right here. So I'm going to plug the variac in, and I'm going to gradually raise the DC bus voltage, and you can see our load is coming on. The load is being driven from the IGBT, that U high side IGBT. Now we're going to get close to that oscilloscope so you can see the output waveforms of that U high side IGBT. Put this pencil down. I'm going to move the scope in front of the camera. Now right now we're at 100 volts peak. I have a times 10 probe out there, and we're set to 10 volts per division. 10 times 10, 100 volts per division. And we're just a hair over 100 volts peak. And we're running at 53.7 hertz. That's the output frequency of that 555 timer driving into that optocoupler's input LED. Whose output side is turning that NPN transistor on and off that's driving into the gate of the IGBT. Now what we need to do is test the other 5 IGBTs. Okay, I'm setting the variac to 0 volts. I'm going to unplug the variac from the power strip, and now the output of the IGBT is turned off. Now I can turn off the 2 external power supplies. You want 0 volts across the collector emitter of that IGBT before you remove the gate wiring. That way you don't accidentally turn that IGBT on when it should be off. According to our documentation, the V high side IGBT is right here, and that's VP1 is VCC, and that's on pin 6, and VPC is on pin 4, and VP, the gate of the IGBT, is on pin 5. So we're going to move our wiring here. All the power supplies are turned off. We're going to move plus 15 volts to pin 3. The gate wire from our transistor to pin 5, and our ground of the 15 volt DC power supply to pin 4. Now we have the gate circuitry wired up. We're going to move our black wire to the V terminal. Now all this will make sense when I explain the paperwork, when I explain my drawings. And we're going to move our red wire, our light bulb load, to the P terminal. It's turned all the way to 0 volts. Let's go back over in front of the oscilloscope. Okay, I'm turning on the 5 volt and 15 volt power supplies. I'm plugging in the variac. I'm raising the AC voltage of the variac that's going into that bridge rectifier being filtered by the bus capacitor. Right there we have 100 volts peak. That's good. 4 more IGBTs to test. Now y'all don't need to see me test those other 4. It's the same as testing these 2. But I'll show you how they get hooked up when we go to look at the paperwork. I'll do that when I get to the house. We'll see you there. Even though made it home from work. And here's the pinouts of the IGBT PM15CKF120, manufactured by PRX. Now, pins 1, 2, and 3. This is for the high side U circuitry. 4, 5, 6 is for the high side V circuitry. 7, 8, and 9 is for the high side W circuitry. Now, this over here are for the 3 low side U, V, W, and fault out. 10, 11, 12, 13, 14, and 15. This terminal right here, this is our plus bus connection, the P terminal. This terminal here is for bus ground connection. Here's our U, V, W terminals for the output of the IGBTs to the motor. Here are the three high side circuits to fire into the gates of the three high side IGBTs of U, V, and W. Down here are the three low side firing circuits that drive into the gates of the low side U, V, and W. The high side IGBTs common to the P terminal and the low side IGBTs common to the N terminal. Now on this particular IGBT, you have to power up these individual firing circuits. On 3 and 1, we apply 15 volts DC and ground from an external power supply and 15 volt peak square wave into 2. On 6 and 5, or 6 and 4 I mean, we apply the plus 15 volts and ground and 15 volt peak square wave to terminal 5. On 9 and 7, we apply 15 volts DC and it's ground, terminal 9 being plus 15, terminal 7 being ground, and the 15 volt peak square wave on terminal 8. Now on the low side, you only have to apply, up here we individually applied, as we were testing U, V, and W, we individually applied that 15 volts DC and ground to these three circuits, depending on which one we were testing. But on the low side, you only have to apply one time to test all three, the 15 volts DC to pin 11 and its ground to pin 10. The 15 volt square wave on pin 12 for the U low side, the 15 volt square wave, a peak, on pin 13 for the V, and the V low side, and pin 14, the 15 volt peak square wave for the W low side. Now let's see how we hook all this up using two light bulbs as the load for U, V, and W. Good morning all. Let's talk about the hookups so that you can test your IGBT. Now first, let's look at the variac circuit that makes the DC bus. Here's our variac, and it plugs into the wall. Now here, I used 120 volts AC single phase to the line in plug. The output is AC, and it's variable. You turn this knob, increase the voltage output or decrease the voltage output, depending on which way you turn that knob. Our bridge rectifier here converts that AC to DC, which is filtered by these two series bus capacitors. Now I used 3300 microfarad, 3300 microfarad at 450 volts each. And that is how we make our DC bus. Now let's look at the gate driving circuit that I put together. See if I can get centered in the frame here. Here's a 555 set up in astable mode, and that outputs a square wave that drives into the input LED of this optocoupler, part number CNY17-2. Now this green LED right here with the 220 ohm current limiting resistor is just an indicator to us that 555 timer IC is outputting a square wave. Now on the output side of the optocoupler, we have an emitter going to a 220 kilo ohm resistor that's connected to the gate of our driver transistor right here, MPN. Now we have a pull down resistor right here of 10 kilo ohms. Now, what that does is that ensures that this transistor's off when there's no base voltage applied to it. So when the output goes high through the NPN transistor inside that optocoupler, this transistor is turned on. And this point right here would go low through the base emitter junction. When this transistor is turned off, then 0 volts is applied to the gate. And that would turn off that, applied to the base, I'm sorry, and that would turn off that NPN transistor, at which time the output would go high through this 1 kilo ohm half-watt resistor. Now we're using 15 volts here on the gate side. The gate of that IGBT requires plus 15 volts to turn that IGBT on. On this side, you can either use that same 15 volts, but I used a separate 5 volts on the NE555N side. So 5 volts over here, 15 volts over here. And you can notice I have two ground symbols. This is the 5 volt ground, and this is the bus ground, the IGBT bus ground that we created over here. So separate power supplies. Probably a good idea anyways to use separate power supplies since you have a high voltage over here and a low voltage over there. Now let's look at one of the gate circuits. We're going to look at, let's see, which one do we want to look at first? Let's look at the low side UIGBT that we're going to test. This IGBT right here is the one we're going to test. And we apply that same 15 volts that's over here to pin 11 of the IGBT and bus ground to pin 10. Now all the low side IGBTs, the power supply to power up that gate driver circuit inside the IGBT is on 11 and 10, all of the low side. So we have two series light bulbs. This is plus bus that we created with the Variac on this side of the light bulb. The other side of the two series light bulbs connected to the U terminal of the IGBT, and that's in the collector of the low side IGBT. Here the N terminal is connected to bus ground. Let me draw that in there. I didn't draw that in there. We'll put bus ground right here. Okay, so when we apply a square wave from our driver circuit into pin 12, that turns on and off this IGBT right here, turning on and off the lights. Our two series 120 volt AC 100 watt light bulbs. Okay, that's low side U. Let's look at low side V. Very similar setup. Here's our same plus 15 volts going to pin 11, our bus ground on pin 10, and our ground right here to the N terminal. The V terminal is connected to this side of the light bulbs. The other side of the two series light bulbs is connected to bus plus that we created with the Variac bridge rectifier and bus capacitors. Again, we have a square wave coming into pin 13 this time, and that turns on and off the low side V IGBT, and that turns on and off our light bulbs. Bus plus, V terminal, down to the N terminal, bus ground. Here's low side W. Same thing, plus 15 volts is still on terminal 11. Bus ground is on terminal 10. Our N terminal is tied to bus ground. Bus plus this time connected to the 2 series light bulbs, connected to the W terminal. And when we apply a square wave, this time to pin 14 of that IGBT package, that turns on and off the light bulbs through the low side W IGBT. Our path would be in this direction. Now we get a little bit different. Here's high side U IGBT right here. Now the U terminal is connected to the light bulbs, but the light bulbs series is connected to bus ground of the Variac bridge rectifier bus capacitors on the ground side. The P terminal this time of this high side is connected to bus plus that we created with that Variac bridge rectifier and bus ground. Here's where we get a little bit different. Instead of 11 and 10, we had to move our plus 15 volts to pin 3, our bus ground to pin 1 of the IGBT, and the square wave from the driver circuit that we put together goes to pin 2, and that turns on and off the U high side IGBT. And now our path is from the P terminal plus bus out the U terminal to the 2 series light bulbs to bus ground. Here's V high side. The light bulbs are now connected to V. The other side of the light bulb is connected to bus ground. The P terminal is still connected to plus bus. We move plus 15 volts DC from that external power supply to pin 6. We move it from pin 3 to pin 6, and we move bus ground from pin 1 to pin 4. And we apply the square wave from our driver circuit to pin 5. And that turns on and off our V high side IGBT. So now, plus bus turning on and off through the IGBT out to the light bulb load to bus ground. Is this the last one? I think it is. Have you noticed we're only checking one IGBT at a time? So we're checking the high side W, but the low side W we're ignoring. We're only checking the high side W. Here, plus bus on the P terminal still. W out to the light bulbs. The other side of the light bulb's connected to bus ground. And now we move our plus 15 volts DC from pin 6 to pin 9. And our bus ground from pin 4 to pin 7, with our square wave applied to pin 8. That turning on and off this IGBT, which in turn connects our light bulb load up to the bus terminal. So bus plus through the IGBT collector emitter, out the W terminal, through the light bulbs to bus ground. So on the high side we had to move that plus 15 volts in bus ground each time we moved to a different IGBT. Whereas on the low side we could keep the IGBT on 11, or I'm sorry, the plus 15 volts on 11 and ground on pin 10. I'll put all these pages up at the end of the video, and that way you can test your IGBT. About the most difficult thing is being a little bit careful with the power supplies, especially the high voltage DC bus and bus ground that we created with the Variac bridge rectifier and bus capacitors. These bus capacitors, they'll hold a charge for quite a while. So what I do is, while that IGBT is still firing from our gate driver circuit, I will turn the Variac to 0, and that will discharge these bus capacitors because they're no longer being supplied from the AC bridge rectifier, because this is now 0 volts. These bus capacitors will be discharged through the IGBT and light bulbs. And then I'll turn off the Variac and then turn off the supplies, the 5 volt and 15 volt, two separate supplies, and then make the changes to the gate circuitry and the power supply circuitry. But you want to make sure that you don't get yourself lit up. These capacitors, they will hold the charge. Okay, I think that's everything. I'll put this video up tonight when I get home. Did I miss anything? I probably did. You know me. I get to yammering on too much sometimes. Okay, let's get out of here. We'll see you in a little bit.